Do you ever go to the gym and wonder why the last reps of your exercises are so difficult? If they're not, you're not training hard enough, but if you are, here's why. Acute muscle fatigue is the temporary decline in a muscle's ability to generate force or sustain a particular level of intensity during physical activity. This causes temporary decreases in muscle strength, muscle endurance, and overall performance, especially when working at the higher intensities. It is good to know that muscle fatigue cannot be determined by a single factor and has multiple causes, but first, we need to understand how muscles contract in the first place. Muscles contract via a process called excitation-contraction coupling, where the brain communicates at special junctions known as neuromuscular junctions to initiate a contraction. Firstly, an action potential is initiated from the brain or spinal cord, sending a signal through the motor neuron, releasing a neurotransmitter called acetylcholine, which initiates the muscle action potential. This leads to the activation of ion channels, causing an influx of sodium ions and an efflux of potassium ions within the muscle fiber membrane. This ultimately triggers the release of calcium ions from the sarcoplasmic reticulum, binding to troponin, a protein associated in the muscle fiber that leads to a conformational change, allowing the muscle to work and contract. Now, what happens when a muscle keeps contracting? What changes occur to this process, causing our muscles to fatigue?
Our muscles become weaker during intense exercise as the amount of calcium ions inside them decreases. Here are some examples. During intense exercise, ATP, responsible for powering the calcium ion pumping muscle enzyme SCRCA, decreases, causing intracellular calcium to decline. Additionally, magnesium ion concentration also increases, preventing calcium from binding to ryanodine receptors, which are responsible for regulating the release of calcium ions into the sarcoplasmic reticulum. It can block calcium since magnesium has a higher affinity than calcium to ryanodine. Additionally, phosphate ions competitively inhibit calcium ions from binding to troponin, further reducing calcium ion concentration within muscle cells. What does this look like? Decreased force production and impaired coordination.
Now we know how muscles may fatigue, but we also need to consider the type of muscle fiber. The body consists of type 1 and type 2A or B, each being more dominant in different types of exercise. Our type 1 fibers, or slow twitch fibers, are slow to fatigue and therefore utilized during more endurance-based exercises like marathon running. These fibers have more mitochondria and capillaries per motor unit and therefore more calcium to cause contraction for longer without rapid fatigue. On the other hand, type 2AB fibers, more specifically type B, function almost the opposite. These fast twitch fibers are vital for explosive exercises like sprinting. Both have fewer mitochondria and capillaries and therefore can't contract for as long before fatiguing, unlike our type 1 fibers. There's still a lot of research to be done to find out how different factors cause muscle fatigue, but hopefully for now you at least know why you're in so much pain after the gym.